This video to hopefully support some students as they are struggling with this homework assignment. This is Unit 2, Lesson 4 homework. So we talked about scale drawings, and scale drawings are two-dimensional representations of actual objects or places, such as a basketball court or a blueprint of a house. Okay, the scale tells you a scale tells you how actual measurements are represented on the drawing. For example, if a drawing has a scale of 1 inch to 8 feet, then a half-inch line segment on the drawing would represent the actual distance of 4 feet. Okay, all right. So here is a part of a scale drawing of Zara's office. The scale is 6 centimeters to 15 feet. So what are the dimensions of the actual office? Well, if we know that 6 centimeters are 15 feet, how do we figure out what 2 centimeters are? Well, I know that to find the scale between these two, I have to find my unit, essentially. So I know that if I have 6 centimeters to 15 feet, I hate that I can't draw on this properly. So 6 over 15 compared to 1 over x. Okay, so I'm trying to find x. Well, I know that in order to get to 1, I have to divide by 6. So 15 divided by 6. What's that? Well, I know that it's more than 2. So I subtract 3. So I know that it's going to be 2.5. Okay, so my scale is 2.5. So I have to then multiply this number here by this number and by this number. So 2 times 2.5 is going to be the length, or maybe that would be the width. Either way, I don't know if this is L and this is W, or if this is W and this is L, but figure that out. 2 times 2.5 is what? 4 times 2.5 is what? And then find the real area. Okay, you know that 2 times 2.5 equals 5 feet. Okay, and you know 4 times 2.5 is 10 feet. So now you can find the area. All right, problem 3. Here is a part of the scale of Zara's office. Here the scale is 6 centimeters to 15 feet. It's the same scale. Zara wants to put a couch that is 3 feet wide. How wide would the couch be if it were drawn on the scale drawing? Well, we just figured out that 2 centimeters is actually 5 feet in real life. And we know that this right here is 10 feet in real life. So how wide would the couch be if it were drawn on the scale drawing? Well, we know it's 3 feet wide. So we know that it would be part of this. So basically what we're doing, going back to our table here, we have 2 centimeters something centimeters to 3 feet, and we have 6 feet to 15, or 6 centimeters to 15 feet, and we know that the difference between this is 2.5, and we know that 1 was 2.5, so I have to divide 3 and 2.5. So 2.5 goes into 3 one time, and I put my decimal, and I know that that's going to be 0.5, bring down a 0. Oh, I'm sorry, I'm doing that wrong. What am I doing? I'm going to do 25 divided by 3. I'm going to put decimal here, 30. 25 goes into 30. I am confusing myself. One time. It's still 5. That's going to be 0. 25 goes into 52 times. Oops. 1.2 minus equals 0. And then I already moved my decimal point, so we're good there. So here we are, 1.2 centimeters. So what I would say here is 1.2 centimeters. That's what I would say. And you've kind of shown me your work already, if you do something like that. All right, Fabiana's office is near Zara's office and measures 4 centimeters by 8 centimeters in the scale drawing. Is Fabiana's office twice the area of Zara's office? Well, we know that Zara's office is 2 by 4, so if Fabiana's office is 4 by 8, is that twice as big as this? Well, 2 times 2 is 4, 4 times 2 is 8, so the answer then would be, okay, and then you can explain it. Problem 5. Jada is looking at a map of a square park that has a scale of 5 centimeters to 200 feet. So every 5 centimeters is 200 feet. Jada lives 500 feet from the park. How long would this distance be on the map? Okay, well, we know that this is 10 centimeters, and that's going to be, well, half of this is then going to be 200 feet. So the other half is going to be another 200. So this 10 centimeters right here is 400 feet. So if she lives at least 10 centimeters, because that's 400 feet, I have to figure out what is 100 feet. If 5 centimeters is 200, how many centimeters is 100? Well, half of 200 is 100, so half of 5 is 2.5. So I know she's going to live 10 centimeters and 2.5 centimeters. So 10 plus 2.5 is 12.5. And that's how many centimeters that she would live away from the park. Okay, problem 6 and 7. So same scale, 5 centimeters to 200 feet. If Jada ran around the perimeter of the park once, what distance would that be? Well, one side of the park we already decided was how many feet. If 5 centimeters is 200 feet, how many feet are 10 centimeters? The answer is 400 feet. And if we want to know what the perimeter is, 400 plus 400 plus 400 plus 400, how much distance would that be in feet? And then how many times would Jada need to run around the park in order to run a mile, or 5,280 feet? Well, once you've figured out your perimeter, you can then divide that number by this and then figure out how many times that would take her to run. Here's a scale drawing of Lafayette Square in Washington, D.C. The scale is 1 inch to 200 feet. Determine the actual dimensions of Lafayette Square. So we have our length and our width. So if 1 inch is 200 feet, 4 inches is how many feet? And then if 1 inch is 200 feet, how many feet are 2.5 inches? Well, 2 inches would be 400 feet, and then half an inch would be half of this. So figure out that answer. This one was hard for a couple of people. I'm not going to go over it in this video because I have a whole separate video just for this question, and I will send that video to you. Okay, so what is the area of polygon Q? So here's polygon Q, and we have to figure out what the area is. So with this one, personally, what I would do is I would draw myself a rectangle all the way around it and find the area of that. And I see that that is 2 units by 1, 2, 3 units. So my area of this whole thing would be 6 units. But then I know, well, I have to figure out that this, because this is cut off, is not going to be a full area there. So I have to figure out what the area of this is and cut it in half. So this is 2 by 1, so it's going to be 2 units. Cutting that in half is 1 unit. So my original was 6 minus 1 is 5. So right now I'm at 5 units squared because I got rid of this part right here. Now I have to do the same thing right here. Well, 1 by 1 is going to be 1 unit. To cut that in half, that's going to be half a unit. So then I'm going to subtract 0.5 of a unit. So now I have a 4.5 units squared. That should be the right answer, and I'm not exactly sure yet. Okay, so it says we haven't completed it, so it won't tell me if it's correct. If she drew a scaled copy of polygon Q using a scale factor of 2, it's going to be 2 times as big. So what's your area going to be? 2 times as big as our area, which is going to be 10. So let's see what that looks like. If the area of the first, of the pre-image is 4.5 and the scaled copy is twice as big, the area is going to be twice as big. Unless I'm thinking of that wrong. 1 out of 2 is correct. So this one is not correct. So we need to think about that again. What is the area of, if she scales everything up by 2? Well, I'm going to draw it. So if I have 3, then I know my new part of this is going to be 6. And this is 2, so I know it's going to be 4. So far, if I were to draw a complete, and of course this thing doesn't have enough squares on it, but I know that this is going to be 4 by 2. So I'm going to have to do the same thing that I did before to cut that in half. So let me just see what that's going to be. So wish I had 6. I wish I had enough to actually draw it. So I know that 6 times 4 is 24, and I know that this right now is 2 by 1. So that's 2, but if I make it twice as big, it's going to be 4 by 2, which is 8. Cut in half is 4, so now I have to subtract 4 from 24. And then I know that this is 1 by 1. Doubled is going to be 2 by 2, which is also 4, so half of that is 2, so I have to subtract 2. So my new area is going to be 18 units squared. It's really hard to explain that on here because I can't really draw it to show you. So scaled copy is twice as big. I will take the measurements of my drawn rectangle and cut parts of it off. That's not a great explanation, but I'm just going to leave that there for now. So now it's saying that's correct. All right. That's a very quick run through of the homework. I still want you to try it on your own. Even if it's a little bit confusing, I want you to kind of think through some of these problems and do the best you can. Tomorrow in class, we will take the first maybe 5-10 minutes to go through it and see how everybody's doing, and kind of reteach some of these concepts that are a little bit more confusing. Okay?